We're going to take a look at solving systems of linear equations using the substitution method. Now, equations can come any forms. The most recognizable would be the slope-intercept form, also known as y equals mx plus b, or the standard form, also known as ax plus by equals c. So we'll look for that, and that's more common, but it can come in any form. And one of the things you want to think of is, what does the solution actually find? It's going to help you understand this. It's going to find the point that is on both equations. That is what's right here, so it'll be true for both. So it's when x and y are the same, they are equal. So let's first take a look at the example where we're given a system and we're going to show that it points a solution. So if 3, -2 is a solution to the system, that means when x equals 3 and y equals -2 will be true for both equations. So if we look at the first equation, 4x, so I'm going to do 4 blank, minus 5y, 5 blank, equals 22. And I'm just going to substitute in the 3 and the -2, 3 for the x and the -2 for the y. And we have 12, and this would be plus 10. And we're going to check to see if that equals 22. And yes, 22 equals 22. So we haven't proven anything yet, just that this point is on our first equation, the graph of that equation. So now we'll go to our second equation, which says that y equals 2x minus 8. So we're going to have our y value equaling 2 times our x value minus 8. We want to be careful here to make sure we substitute correctly. X was 3, so that's going to go here, and y was -2, so that's there. So we have 2 times 3, which is 6, and we have 6 minus 8, which is -2, which matches our -2 on the other side. So it is true for both equations, so it is a solution to the system. Now let's take a look at the different examples you'll come across. The first ones I consider the easy ones. And the reason for this is that x or y is already isolated. So in our first example here, our first equation, it has y equals. And we know that y is going to be equal to -3x plus 9. So we go to our second equation, and wherever we see y, we're going to replace it with what it equals, which is that -3x plus 9. So I'm going to leave it blank for now and finish writing this down. So we have 2 times y, but again, y is really going to be -3x plus 9. So that's this piece right here. And once we've done this, we've eliminated one variable, and we have one variable in the equation, just x. So we'll solve it the way we've done any equation. So we'll go ahead and distribute that 2, and we'll have -6x plus 18 equals x minus 10. And then we're going to finish solving by just moving the x terms to one side. I'm going to move the -6x over and bring it to that side, and we'll have 7x. That term is gone. And I'm going to move the minus 10 to the other side. And then we're going to have equals 28. And we'll divide both sides by 7. So we can see we end up getting x equal to 4. But remember, we're not done yet because we also need the y coordinate. So we can plug this back into any equation we want, but rather than go to this one, I'd rather go to this one where y is already by itself. This says that y equals -3 times whatever our x value is plus 9. And we just solved for that x value. We found out it was 4. So y is going to equal -12 plus 9, or y is going to equal -3. So our solution can be written as a point. It's the point 4, -3. So there is one solution where they intersect. Example number 2, same idea, but instead of y equals, we have x equals. And that really doesn't change anything, just the fact that it's x we're going to be replacing in the other equation. And we'll be replacing it with 2y plus 3 because it's already isolated. So let's go ahead and write this down. We're going to have 4 times whatever our x value is, minus 7y equals 11. And again, x was equal to 2y plus 3, so where we had x, we're now going to write 2y plus 3. And again, this is a case where we'll distribute through the parentheses, and we get 8y plus 12 minus 7y equals 11. And we'll just combine our like terms. We have 8y minus 7y. That's just going to give us y, so we have y plus 12 equals 11. And we'll subtract 12 from both sides to finish this. And we have y equals -1. But again, we're not done. So we're going to take that y equals -1 and go back to our first equation where it's x equals. So x is going to equal 2 times our y value plus 3. And again, our y value is -1. So we have x equals -2 plus 3. So x equals +1. So our solution is the point 1, -1. Our third example, again, is still pretty easy. Some people get confused because we have two variables that are already isolated. We have y equals something, and we have y equals something. This doesn't change anything. It's actually a little easier. So we know that the y values will be equal. So we're basically setting 3x minus 2 equal to 2/3 x plus 68. Or, same idea, we're going to substitute in. We're going to have 3x minus 2 substitutes in for the y, and that equals 2/3 x plus 68. Now, I know there's something about this equation you don't like, the fact that there's fractions. We can deal with that right away, or we can wait until we run into a problem. Let's wait a minute and see what happens. So if we move the -2 to the other side, we end up with 3x equaling 2/3 x plus 70. Now, if we don't want to go subtracting fractions and we're looking for common denominators, what we'll do is we're just going to go ahead and multiply this entire equation by that denominator of 3. So this was called clearing fractions. And in doing so, we multiply 3 by everything. So we're left with 9x equals, and 3 times 2/3 x is just 2x, because those 3's will cancel. And 3 times 70 is going to be 210. So we'll move the x's to one side, so our variables go to that side. So we're left with 7x equals 210. Dividing by 7 leaves us with x equaling 30. And again, we're going to take that 30 and we're going to substitute it into one of these equations. And it really doesn't matter. So again, we have x equals 30. So I'll go to the first equation so I don't have to deal with that messy fraction. And we have y equals 3 times that x value minus 2. So we have 3 times 30. So we're left with y equals 90 minus 2, or y equals 88. So our final solution is the point x is 30 and y is 88. Now, we're going to do some examples that require a little bit of work. And what I mean by that is it's not in x equals or y equals forms. So if looking at both of these equations, the one that looks most like the form we want is the first one, because there is an x with no coefficient. In other words, it would just be 1. So I'm going to look to isolate this x. That means we're going to have to get rid of this minus 2y. So let's write this down over here. We have x minus 2y equals 3. And if I want to get rid of minus 2y, we'll add 2y to both sides. So this is going to leave us with x equals 3 plus 2y. So we can't combine those terms. But the good news is we have x by itself. It's x equals 3 plus 2y. So we go into the second equation and we look for that x value, which is right here, and we're going to replace it or substitute. So we're going to have 4 times the x minus 7y equals 11. And our x value was 3 plus 2y. And again, we're going to go ahead and distribute. So we get 12 plus 8y minus 7y equals 11. We can go ahead and combine these like terms here of plus 8y minus 7y, which is just y. So we have 12 plus 1y, or y, equals 11. And we'll go ahead and subtract 12 from both sides. So we're left with y equals -1. Now, we have the first equation or the second equation we can substitute back into, or any form of that equation, which is this easy one right here. So we're just going to go ahead and substitute into here. So we're going to have x equals 3 plus 2 times whatever that y value is. And that y value we found to be -1. So we have x equals 3 minus 2, or x equals 1. So we have a solution of 1, -1. And that sounds familiar. Our next example looks very complicated because we don't have an x or a y without a coefficient, or I should say with a coefficient of 1. But if we look at this first equation, notice that they're all even numbers. So what if we were to take this first equation and divide this entire equation by 2? Look what we get. We get x minus 2y equals 3. And we can do that because we're dividing both sides by 2. So now it's a much easier form where we can isolate this x by adding 2y to both sides. We now have x equals 3 plus 2y. I think you guys know where this is going. So we have x is isolated here. We have an x over here. We're going to go ahead and substitute. So we're going to have 4 times our x value minus 7y equals 11. And yes, it is the form of that last equation we just did. And we have 3 plus 2y. So we're going to go ahead and distribute. We're going to get 12 plus 8y minus 7y equals 11. And we're going to combine these two terms here, which is going to give us just 1y. So we're going to have 12 plus y equals 11. Subtracting 12 from both sides, we get y equals negative 1. And we're going to substitute it into our easiest form. So we have x equals 3 plus 2 times whatever that y value is, which was negative 1. So we have x equals 3 minus 2, x equals 1. So again, we have 1, negative 1. So I've just taken an equation and looked at different forms of it to show you can solve it any way. Now we're going to look at two of the special cases. And you'll see why they're called special as we go through them. And there are different strategies to solve these, but let's just go ahead and go straight through it with our technique for substitution. So in the first equation, we see we have x plus 2y equals 5, and in the second it's y equals negative 1/2 x plus 5. So some people might get x by itself here, but we already have y by itself. So in our second equation it says y equals, so we're going to go ahead and substitute our value for y into that first equation. So that means we're going to have x plus 2 times whatever that y is equal to 5. And y was negative 1/2 x plus 5. We're going to go ahead and distribute. Give ourselves a little space here. So we're going to have x plus 2 times negative 1/2 is going to be negative x. And then 2 times 5 is 10. So plus 10 equals 5. Now we're going to be left with x plus negative x. And together, we know that they're just going to combine to make 0. So we're left with 10 equals 5. And you should know when you come across an equation where you have a false statement or a lie that this is impossible. So that means there is no solution. And if you learned about graphing systems of equations, and there's a symbol for no solution, if you learned about graphing system of equations, that means these two lines are parallel, right? So you have two parallel lines. So other strategies for this is to put them both in slope-intercept form, y equals mx plus b, and see that they have the same slope, is what you would have, but there'd be a different y-intercept, different points, which means they'll never intersect, so there's no solution. Number 7, again, we see that we have y by itself, and we're going to go ahead and substitute that into our first equation. I'll do that down here. So we're going to have 10x plus 8 times that y value equaling 16. And that y value was negative 5/4 x plus 2. So we're going to have 10x, and we're going to have to go ahead and distribute this 8 to both pieces. So 8 times negative 5 is negative 40. Divided by 4 is going to give us minus 10x. Then we're going to have 8 times 2 is we're going to have plus 16 equals 16. And again, we have 10x minus 10x, so they're going to combine to make 0, and we're left with 16 equals 16. Now this is a statement that is always true. And if you come across something that's always true, that means there are going to be infinite solutions. It's a dependent system. So the x and y values where they intersect are going to depend where you choose. It means that they are the exact same line. So this system right here, these two lines are the same line. So they intersect everywhere on where those values are true. Okay, so we have cases where there's one solution, where there are infinite solutions, and where there are no solutions. Just be careful the way you substitute things in. Do your work step by step, and you'll be fine.